Hello everyone. Today we are going to take a look at UNISA Computer Science Year 1 modules. And you might be asking yourself, why are we doing this? Well, on the UNISA website, the description for the modules, especially for computer science, are not very descriptive. And this video serves as just a bit of an introduction into what you might be learning about in your first year doing computer science at UNISA. So here's a list of the modules that relate to computer science specifically. Firstly, we have Theoretical Computer Science 1, Introduction to Programming 1 and 2, Computer Systems, Fundamental Concepts, Linear Algebra 1, and Calculus A, which is mandatory for computer science degrees, regardless of the combination. But for BSc Computing, it is listed as an optional elective. Although I recommend doing Calculus A. It is the basics of calculus and it could be important for just reading overall mathematical things, Calculus B, however, is only if you take a combination of computer science and applied maths and computer science and mathematics. And I lined it out because in this video we will not be covering that. We will only be covering up to Calculus A, alright? So COS 1501, Theoretical Computer Science 1, the description online states, to introduce students to some concepts from discrete mathematics as a theoretical foundation for computer science. This background is relevant to relational databases, the development of probably correct programs, and the analysis of algorithms. Let's take a look at what that actually means. So immediately you'll be learning about various logical symbols given in the table below, as you can see. You'll learn how predicates and symbols are used to represent properties or relations, all formulated as English sentences, which is quite interesting. You can pause the video and read below. And don't worry if you don't understand any of the symbols on the right. They do teach you that and you will be able to read that. They tell you how to draw and interpret truth tables, which can be useful. Also how to write proofs like direct proof, proof by contrapositive, and proof by contradiction, just to name a few. And below I give an example of a direct proof. They tell you how sets are represented and also set notation, that you can read and properly mathematically write sets yourself. They also show you how sets are represented using Venn diagrams to easily visualize how sets are interacting with one another. And they take a detailed look into relations on functions and sets themselves, which is a lot of learning. Obviously to remember what's reflexive, what's symmetric, what's transitive, what's an equivalence relation, but it's really just studying and applying. It's not too difficult there. Next module we have is COS 1511, Introduction to Programming 1. Now the description for this is very, very vague. To provide students with an introduction to programming and to cover the fundamentals of control structures, problem-solving techniques, and the incremental testing of programs. Like I said, guys, a bit vague, so let's have a look. One thing to note is all programming will be done in C++. Here is an example of C++ down below. Just take note of that using namespace SC on line 2, do not do that. That's not good practice. Alright? Data and control structures is something you'll also have a look at. As you can see in the picture, there's things like while loops, do while, for loops, continues, breaks, switches. There's a ternary operator, if else, you get the idea, right? It's all control structures that you might be useful from IT in high school, or if you did some other computer related thing, you might be useful or used to this, I should say. You then learn about input and output of data from and to the standard input-output streams and how this can be done in C++, specifically writing to the console and taking input from the console, from the user, right, using stdc in and stdc out. They teach you the basics of that. You learn about data types and structures, i.e. floating point, integer, character, string, boolean, 1 and 2 dimensional arrays, etc. Right? There's a whole table of data types down below, which you can see the primary ones, derived ones, user-defined ones. There's a lot of them that you learn about. You learn about functions with both reference and value parameters, as well as structs. Okay, so on the left you'll see two types of functions. Is there two types? No, I think this is just one type. Okay, just one type of function. And on the left it is the reference type parameters. And you'll learn what that means, that little ampersand n1, ampersand n2 in the parameter list. You will learn what that means and how to use it, when to use it, etc. And on the right you will learn about structs, which are basic user-defined data structures. You know, it's like a watered-down class, if you know what a class is. Okay. Then we move on to COS 1512, Introduction to Programming 2. This is to introduce students to the detailed design and implementation of algorithms as programs, and includes the fundamentals of simple data structures with object orientation. What does that mean? Let's have a look. Right? You'll learn how to design a logical solution to a programming problem and identify the steps needed to solve the particular problem. So this means they will give you a word problem, and you would need to design a solution for that, aka a program to solve that said problem, and implement it and make sure you understand the flow of it, how it solves the problem and how it avoids any bugs, etc. Right? Checks inputs, you get the idea. That's an important skill. Next, you'll learn how to overload functions in C++. As you can see in the illustration down below, you have a function and it's same function name, but it can have multiple input types. Right? That's what overloading is. You'll learn pointers and what they are, how to use them, etc. And they are a big part of C++ programming. So this is an important chapter to really understand. In the picture you can see int value 23. That value is saved at some memory location number 4590, which is not how memory is stored, but that's just a number to make our lives easier right now. You then make a pointer and it takes in the reference of that value, which is above, you can see 23. And then you change the value at that memory location to 49. You can see it's the same memory location, but the value is changed. Cool, right? You'll learn more about that. You'll then learn about classes, objects, and inheritance. Specifically, you'll also probably learn about the OOP principles in general, abstraction, polymorphism, I forget the other two. There's two more, okay? Anyway, you can see down below there's a class. You get the access specifiers. It can be private, public, protected, etc. You'll learn what that means. You'll learn what it means to have data members, member functions. You'll learn all of this. You'll learn how to overload operators in C++, okay? In the example down below, they overload the operator plus so that you can add two objects together, complex 1 and complex 2, which are complex objects. Okay. Without overloading that operator, you'll get an error because you cannot add together objects. You can only add together numerical data types unless you do what you do here, overload the operator. Cool. There's much more operators. There's different types, and you learn how to overload them all. You learn what recursion is and templates. On the left-hand side, you can see an example of recursion, which is just recursively calling the function within the function until some stopping condition is met. It's a bit of a pain to read and work through the logic, but it is less code to write. In practice, in the real world, you will rarely use recursive functions because they are very hard to read. All right. On the right-hand side, you'll see templates, which is an extremely powerful part of C++. In that you can template a function or a class and allow it to work with any data type that the user or whoever desires. All right, very useful. Next is COS 1521, Computer Systems Fundamental Concepts. And the description for that is to introduce students to the computer as a system. This covers hardware concepts such as internal representation of numbers and characters and basic computer architecture, and software concepts such as system software and application software. It also includes a brief introduction to databases and to systems analysis and design. You will learn how data is represented, manipulated, and stored in a computer using different number systems. As you can see, you might be aware of, I don't know, maybe not, there's different types of number systems. There's a decimal number of base 10, binary numbers, which computers love, with base 2, octal numbers, base 8, hexadecimal numbers, base 16, and that is the different types of number systems. You'll learn more about them, how to represent them, how to go from one type to the other, etc. You'll learn about Boolean algebra, which is basically how computers execute functions, execute programs, execute instructions, right? It's all just ones and zeros and logic gates, which you can see down below. There's an AND logic gate, and NOT logic gate, and OR logic gate, with a truth table, well, sort of a truth table down below, and it tells you how that logic gate works. You'll learn about Karnaugh maps and how to use them. You'll learn about the software development process, which you can see down below, which is quite important. You'll learn about the units of hardware and software components. Down below is a good example of something you might look at: the control unit, the ALU, or arithmetic logic unit, which does computations, internal memory, main memory, secondary storage, output devices, input devices, and how the computer interfaces with all these things, how they work together, how they work individually. You'll learn all of this. You'll learn and understand the basics of data communications and networks. On the left we get the OSI model, very popular model in the real life. On the right we get the TCP/IP model, which is what our internet is based off of. Just to add a note, these models are extremely important to understand in the real world. Almost every single workplace will use one of these models to model their software layers, alright? So pay great attention to this. Next, well, everything's important, but I just thought I'd add a little key over here. You'll learn basically to describe data structures and how different databases function. As you can see down below is different types of databases. You'll learn how they store the data on a baseline level, and also how they differ from other databases. What's the advantages, what's the disadvantages, when should you use the one, when should you use the other. Very important for a software developer to know. Then we have MAT 1503, which is Linear Algebra 1. This is very important for computer scientists, and that is why it is compulsory for all computer science related degrees. This module will be useful to students interested in developing the basic skills in linear algebra, which can be applied in the natural sciences and social sciences. Students credited with this module will have an understanding of the basic ideas of linear algebra and be able to apply the basic techniques for handling systems of linear equations, matrices, determinants, and vectors, as well as complex numbers. That's a pretty good explanation, I'm not going to lie to you. Let's have a look at what it might entail on a deeper level. You'll learn how to solve systems of linear equations. In high school, you worked with systems of equations with two variables, x and y, and you had to solve them using substitution and whatnot. Here I gave an example of a system of three equations, which you can still do by hand, but it's a bit of a pain. And then once you get to 4, 5, 6, 7, 8, 9, 10, right, that's when it starts getting ridiculous and you need other methods to solve them, representing them with a matrix and using different methods to solve them in that form. And that's what they teach you right over here. You learn how to perform basic matrix operations. At the bottom I show you how to do matrix multiplication, but you'll learn matrix addition, subtraction, things like that, right? How to, and the rules between them. So when can you do matrix multiplication? Because there is rules, okay? So that's important. Also, you'll learn what a matrix is, by the way. I didn't mention that, but that is definitely something that you will go over. You learn how to evaluate determinants and obviously what they are, and use them to solve certain systems of linear equations and to find inverses of invertible matrices. You'll learn what an invertible matrix is, what its inverse means, and why that's even important, alright? And at the bottom in the picture, I showed you how to calculate the determinant. Alright? You'll learn to perform various operations in 2 space, so xy, 3 space, xyz, and n space. Just goes on forever, alright? A lot of things in calculus extend to n spaces. Okay, even though we only live in 3D space, the rules still apply above that. Okay? And you learn how to find the equations for lines and planes in 3 space. Down below I give you the equation of a line, I show you some pictures. Might be a bit confusing right now, but you'll learn what all of that means. You'll see a plane on the right hand side, you'll do some calculations with intersections of planes, lines on planes, lines to planes, 90-degree lines to planes, things like that, okay? It's quite an interesting one. If you can visualize things in a 3D nature in your head, you'll find this very interesting, and you might do well in the subject. If you can't, you'll need to spend a bit more time, and this will be a bit challenging to you, I must say. You'll learn how to express complex numbers in polar form, solve polynomial equations of a complex variable. Down below I show you polar form of a complex number. I don't show you how to solve polynomial equations of a complex variable, but of course you can go and look at that in your own time if you feel the need to do so. Right? Oh well, right over here is to extract nth roots of any complex number where n is element of natural number. This is basically the same thing as the polynomial equations of complex variables. So you need to find the 3 cube roots of that complex number. You express it in polar form. That's why polar form is important to understand and know how to do. And then you do another formula, which I believe is de Moivre theorem's formula. And then you get an answer, right? And your answer will be 3 roots. Okay, cool. You'll learn how to express relationships between trigonometric functions using complex numbers. Down below is just a simple example, but basically it'll teach you how to go from, obviously, trig, so things containing cosine, tangent, take that to complex numbers and vice versa. Alright, good for simplification and will be useful as a baseline for future mathematical endeavors. Next we have Mat 1512, Calculus A, which is our final subject we will be looking at. This module will be useful to students interested in developing the basic skills in differential and integral calculus, which are essential for the physical, life, and economic sciences. Students accredited with this module will have a firm conceptual grasp of the limit, continuity, differentiation, and integration, together with a background in the basic techniques and application of calculus. Again, a pretty good description of what the module entails, but let's have a deeper look. Firstly, you'll look at mathematical logic and math symbols and the notion of sets. So on the left, you'll see a lot of math symbols. They'll just teach you what a lot of symbols mean, so that you can read in this subject and also future subjects. It will give you a background so that you can understand and read the content in those subjects. For example, on the right-hand side, you see the set theory symbols. Earlier on, when we spoke about sets, you'll be doing this subject alongside that one, so you will get the knowledge of how to read set theory from here and maybe there. They might both speak on it, but you get the idea. Eventually you'll be able to read set theory and other mathematical symbols. You learn the formal definition of a limit and the distinction between the limit when x tends to a and the value at x equals a. Alright? To talk about the definition of a limit, the formal definition, down below I have given that formal definition, and to me personally this gives a little bit of PTSD. I struggle a lot with this formal definition. You might grasp it quickly, but for me I really struggled and I had to go through a lot of YouTube, a lot of practice to properly understand that, okay? And the second part, of course, there is a distinction between when a limit of a value that's converges to a and a value that actually is at a. Alright, that's a bit of a interesting one to look at, and they'll teach you that difference. They'll also show you how to use limits to determine continuity of a function. Down below I show you a bit of an explanation of how you can do that. First you need to decide or work out if a limit actually exists. And to do that, you need to understand that you can approach a limit from the left-hand side and the right-hand side, aka the negative and the positive side. And it's basically saying if those two sides lead to the same limit, then the limit of that function at that point exists. Okay? And there's some rules for a function to be continuous at some point. It must be defined, the limit must exist, and the limit of that function must equal that function at some point c, right? So that's some things that you'll just learn and play around with, do some examples to get the feel for. You'll then learn how to use the squeeze theorem to determine if a limit exists, another method which you can use to determine if a limit exists. And I recommend, if you've never seen visually how the squeeze theorem looks, when you get to learning it, you should probably go look at a video. It's quite interesting and it might stick into your head once you see a visual representation of how this theorem is actually working. I give a little example down below. Once you understand limits, it will make sense of how this is logically possible, right? They tell you what the basic notion of derivative and also first principles are. Now, this should be repeat from high school, okay? Because you did first principles in high school, as you can see on the left-hand side. On the right-hand side, I also show you a little graph of how the first principles looks, okay? And this should just be a recap session, to be honest. Next, they tell you the distinction between continuity and differentiability of a function at a point. So you obviously need to find what's the difference between that two, you know, and in this illustration or this block down below, you can pause it and read it if you're interested. You can see differentiability implies continuity. So to differentiate a function, it must be continuous. But continuity does not imply differentiability, right? Okay. Every continuous function not every continuous function can be differentiable. And one that pops up into my head is I believe it's the Weierstrass function, which you can go check on Wikipedia. This is a function that is continuous, but is nowhere differentiable. All right, it's very jagged up and down. It's an interesting function. Okay, if you're interested, go look on Wikipedia. Pause the video and read this down below. And yeah, they'll also show you the basic rules of differentiation, such as the power rule, product and quotient rule. In high school, we only know the power rule, unless you did add maths, or I think they would teach that in add maths. Then you learn about product rule, quotient rule, chain rule. Again, it's kind of just rules you learn. They are really not that difficult. Differentiation itself is not that challenging. It's integration where, you know, the problems come in, I should say. Okay. You'll learn how to use derivatives to solve applied problems. I couldn't find a good illustration, but down below they give you a population of a city. It's estimated by an exponential function, and they ask at what rate was the population increasing in the year 2010. So t equals 10. They tell you how to solve it, etc. And you could do some interesting things. It just shows you why on earth you're learning about derivatives in the first place. You'll learn about the mean value theorem, which we'll see down below. This can be applied in various other places and will continuously show up in your mathematical journey. I tell you what an integral is and the meaning of it, because we didn't do integration in high school, again, unless you did add maths. Okay, and as you can see in the illustration down below, they're trying to show you that the integral is just the area underneath that curve from point A and B. Okay, this integral obviously has boundaries. An unbounded integral is just the area underneath the curve forever. Okay. They tell you about basic integration and the fundamental theory of calculus. On the left-hand side, you get the basic rules for integration. Again, more rules that you just learn. And on the right-hand side is the fundamental theorem of calculus, which they will spend some time on, and which is quite important to understand. They'll show you how you can use integrals of simple functions to solve applied problems. I have some tortoise example here and some tortoise hare racing, I think. You can read through it if you're interested. Try to do it yourself if you have some knowledge, or ask ChatGPT what the answer is. I don't know. Do what you want with that. That's how the questions kind of look like. Let's continue. You'll learn integration by substitution, which is a bit strange at first, but once you get into it and you've done some examples, you'll understand the steps to do it. All right. it's just another method for integrating a function. And they will go over log and exponential functions, which is in high school, but they'll more do applications of them, and they might go a little bit more in depth into them. All right. And using that exponential knowledge, you'll be able to solve exponential growth and decay problems using elementary, so basic differential equations. As a bit of an introduction to differential equations, very light introduction, so I wouldn't stress too much. And they're not too difficult to solve, and you can read down below what that actually means. All right, thank you everyone for watching. If this was helpful, comment down below, and if you would like to see maybe a year 2 summary like this, please let me know. Please let me know. If you'd like to see a video on anything else related to this, let me know and we'll do that. Thanks for watching, guys. Until next time.